All right, section 6.1, we're going to start looking at systems of equations, which are essentially multiple equations that are interacting with each other. Okay, so you've got a linear system, two lines on the same graph. They might cross, they might not. If they don't cross, that means there is no solution, and we call them inconsistent. Or what that actually means is that they are parallel. Okay, and that means that whatever two equations we're comparing, so if you're looking at two linear models for something, I don't know, price of something and revenue of something, if they're parallel, you're never going to make any money, right? They never interact, so there's no way to know. So we call them inconsistent. A linear system that has one solution is called consistent, and our solution is that point where they cross. Okay? Any linear system with more than one solution must have an infinite number of solutions and is called dependent. And what we mean by more than one solution, it means that we accidentally got the same equation twice. So we took one equation, maybe multiplied it by 5, and then wrote it down again. And so now we've got the same equation written in two different ways, which is dependent system. Okay, there's a handful of ways to solve these. We are going to start with 4 ways. So there's graphing, elimination, substitution, and then we're going to work our way up to matrices. Oops. Okay. Using a graph to find the solution. So if I'm going to graph 2x minus y equals 1, I can use my intercepts. So if x equals 0, then negative y equals 1, which means y is negative 1. So I have 1 point at 0, negative 1. And then if y is 0, then 2x equals 1, which means that x is 1/2. So that's the point 1/2, comma 0. Okay? And then you connect these as neatly as you possibly can. What we're going to end up with is, see if I can do this nicely, something about like that. Okay, x plus y equals 5. Again, I can use my intercepts. So if x is 0, then y equals 5. And if y is 0, then x equals 5. And so I have the point 0, 5 and 5, 0. And so if I connect those dots, let's see about there. Okay, notice that they cross one time, specifically at that point. So you want to graph these as neatly as possible. Not always easiest thing to do, but do your best. Okay. So as I graph those, I end up with the point 2, 3 as their solution. And whatever point that is that they cross, that's your answer. Okay. So you're looking for intersection points specifically. Using substitution. So it is hard to graph, like I mentioned. It's not always the fastest, it's not the best way to do it. So we can use substitution instead. And what substitution does is we take one of our equations. It does not matter which one. Take one of your equations and solve it for one of the variables. So if I have x plus y equals 5, then y equals 5 minus x. And then I'm going to substitute that into the opposite equation, okay? And that opposite is important. If you put it back into the same equation, you're going to get really messed up and it's not going to work. So make sure you're putting it back into the other equation. So if I put this back into the other equation, y is 5 minus x, so 2x minus 5 minus x equals 1. So 2x minus 5 plus x equals 1. So 3x, add 5 to each side is 6, which means x is 2. Now I can substitute back up here and figure out what y is. So y is 5 minus 2, which means y is 3. So these cross at 2, 3, and we just did that example by graphing, and so we know that that's true. We already saw that happen. Okay. Now, solving using substitution. So we're just gonna do it, right? It's already solved for y. So 5x minus 4 times y. Now the first equation says y equals negative 3x plus 5 equals negative 3. So 5x plus 12x minus 20 equals negative 3. 5x plus 12x is 17x. Add 20 to each side. So x equals 1. And if x is 1, we can take that and put it in here and get y. So y is negative 3x plus 5, which means y is negative 3 times 1 plus 5. So y is positive 2. So our solution would be the point 1, 2. All right, so x plus 3 equals 3y. So I'm going to solve this one for x. So I'm going to subtract 3 from each side. And then I'm going to put it back up into this top question. So negative 2x, but instead of x, we're going to use 3y minus 3 plus 6y equals 6. So negative 2 times 3y is a negative 6y. Negative 2, negative 3 is plus 6. Plus 6y equals 6. And then these cancel. So our 6y's cancel and we end up with 6 equals 6. When that happens, okay, we have something that is always true. And if it is always true, that means we have a scenario where we have infinitely many solutions. Okay, and so then we classify this as a dependent solution or a dependent system. It's the same line, it's just written in two different ways. Okay, let's use substitution here. It gets a little trickier, but we can do it. So let's say 5x plus 3y equals negative 7. I'm going to solve for x for no particular reason. So 5x is negative 7 minus 3y. We divide by 5. So x equals negative 7/5 minus 3/5 y. Now I'm going to take that and I'm going to plug it in over here. So 7 times x minus 6y equals negative 20. Distribute that through, and we're going to get negative 49/5 minus 21/5 y. And then I'm going to get a common denominator here. So this is 30/5 y. and I'm going to get a common denominator here as well, so I'm going to multiply by 5 over 5. So I get negative 100 over 5. Okay. Add 49 fifths to each side. So negative 21 fifths minus 30 fifths is going to be negative 51 fifths times y equals, add 49 fifths to each side, negative 51 fifths. So if I divide by that, then y is 1. So the substitution process was messy, but our answer is actually pretty straightforward. So then x is going to be negative 7 fifths minus 3 fifths times 1. So x is negative 10 over 5, which means x is negative 2. Okay. So this system has one solution, and it happens at negative 2, comma 1. Okay. Now, that last example, the substitution wasn't clean. It involved a bunch of fractions. We didn't necessarily enjoy those. That's okay. Okay, there's other ways to approach these. You can use what's called elimination. And in elimination, you're going to choose one of the variables that you want to get rid of first. And it really doesn't matter which one you choose. But there are some times that it's easier to pick one over the other. It just depends on the scenario. And as you do these, you'll start to identify what those scenarios are. Okay. Take a common multiple for that scenario and create a conjugate pair. And I'll show you what that means in a second. And then add those two equations together and then back place. Okay. So for elimination, I have negative 3x minus 4y equals 2, and 3x plus 3y equals negative 3. Okay, before you start doing elimination, please make sure that your equations are in this order. You can do it when they're out of order, you're just not going to like it. Okay, you're not going to enjoy doing it, and it gets a little bit confusing. So make sure that they are placed in an order that is useful to us before we start using them. So you want them written this way first. Okay, now notice right here in the x's, one of them is a negative 3, one of them is a positive 3. And we know that if we add a positive and a negative version of the same number, we get 0. And that's what we're going for. We want those to become a 0 so that we can eliminate them. So if I take these two equations and I just add straight down, negative 3x plus 3x is 0. Negative 4y plus 3y is negative y. 2 minus 3 is negative 1. So then y is 1. And as soon as you know that y is 1, you can take either one of the original equations, does not matter which one, take either one of those, plug in your y value, and get your x. So 3x plus 3 times 1 equals negative 3, so 3x equals a negative 6, which means x is negative 2. So we have an answer at negative 2, 1. To get back to the okay. Negative 2x plus 6y equals 6. Negative 7x plus 8y equals negative 5. Now in this set, they didn't give me a conjugate pair off the bat. They didn't say, hey, here's an easy one, use this number and it'll work, which is okay. Okay, they're going to do that to you quite often. So what we're going to do instead is we're going to pick one of those to get rid of. And so I can get rid of x or I can get rid of y, and it doesn't matter which one you choose. So I'm going to say y. So I've got a 6 and I've got an 8, and I need a common multiple. So both of those go into 24. And in order to turn them into a 24, 8 would get multiplied by 3, 6 would get multiplied by 4. Now, I don't just need them to be a 24, I need them to be a conjugate pair. So instead of multiplying by 4 and 3, one of them is going to be a negative number. So I'm going to take that 4 and I'm going to make it negative. It doesn't matter. I could make the 3 negative. Okay. As long as I'm creating a conjugate pair, it's no big deal. So the equation that has 6y, I'm going to multiply the whole thing by negative 4. And the equation that has an 8y is going to get multiplied by 3. Okay, so negative 4 times negative 2x is a negative 8x. Negative 4 times 6y is minus 24y. Negative 4 times 6 is negative 24. 3 times negative 7x is negative 21x. 3 times 8 is plus 24y. 3 times negative 5 is negative 15. That should be a plus 8x. Sorry. Okay. Now when I solve, 8 minus 21 is negative 13x. Negative 24y plus 24y is going to cancel. And then negative 24 minus 15 is negative 39. So x is going to be 3. And now that I know what x is, plug it into either equation and come up with y. So negative 2 times 3 plus 6y equals 6. So negative 6 plus 6y, or add 6 to each side, so 6y is 12, which means y is 2. So this is the point 32. Okay. All right, this one is going to be your participation quiz for the day. You must use elimination. And make sure that you answer as an ordered pair. Okay, your answer should always be x comma y. Never two separate answers and then circle one. Okay, it's always an ordered pair. And make sure you're being careful to do that because we are looking at graphs and we want things to make sense in terms of graphing so that we get to the right place. All right, so then this thing happens where now our systems get bigger. So instead of having 2 equations and 2 variables, now we've got 3 equations with 3 variables. Okay, so what we're going to do is the same thing we were doing in the last one, we're just going to do it twice. So we're going to eliminate twice. And this starts with picking any variable out of the 3 and eliminating it. And so in this case, I am going to pick z. And the reason I'm picking z is because they're already conjugate pairs, right? One of them is positive, the other 2 are negative. And so if I combine those correctly, I don't have to multiply anything. And the fewer steps that I take to get a solution, the fewer places that there are for me to make an error and get lost. Okay, so we're trying to keep track of all of these things, and so if I can cut that down and keep track of less things, it's easier in the long run. So I'm going to pair up the first and second equations because that's one positive and one negative. And then I'm separately going to pair up the first and the third equation because that is also a positive and a negative. Okay, so we're going to start by eliminating z. Eliminate z. Okay, so 2x plus y plus z equals 6. 2x plus 3y minus z equals negative 2. So 2x plus 2x is 4x, y plus 3y is 4y. Our z's cancel. 6 minus 2 is a 4. Okay. Then take the first equation and the third equation, so negative 3x plus 2y minus z equals 5. So 2x minus 3x is negative x, y plus 2y is 3y, z minus z is 0, 6 plus 5 is 11. Okay. Now what that creates is a new system. And I'm going to take each of these. Now if you want to, you can divide each of these by 4. So I can write this as x plus y equals 1, just for making things smaller. Okay. And then the other equation is negative x plus 3y equals 11. And we're going to eliminate again. So x plus y is 1, negative x plus 3y is 11. It worked out nicely because our x's already cancel. So 4y equals 12, which means that y is 3. Okay. Once I know what y is, we're going to start doing what's called back substitution or back subbing. So if y is 3 and x plus y is 1, then x plus 3 is 1, which means that x is negative 2. And if y is 3 and x is negative 2, then 2 times x plus y plus z equals 6. So negative 4 plus 3 is a negative 1 plus z equals 6, which means that z is 7. Now we still answer as an ordered triple. Okay, so it's no longer a pair, it's an ordered triple. And so we answer in x, y, z. So this is going to be negative 2, 3, and 7. Okay. So this one, I don't really have a bunch of conjugate pairs built in. There is something in the x's that kind of looks like it'll work. 2 of the x's will cancel, and then I can work with one of them and create a 3x and kind of cancel that third one. So I'm going to go with the x's here. Again, it really doesn't matter. Just pick the one that looks like you are able to do it and go with it. All right, so in this one, my first step is going to be to eliminate x. So let's take the second and third. Negative x plus 2y minus 3z equals negative 7. X minus y minus 5z equals negative 24. Okay, the x's are a conjugate pair, so they're going to cancel. So 2y minus y is y. Minus 8z equals negative 31. Now for the next one, I'm going to take the first equation and then I'm going to take the second equation and multiply it by 3 so that the x's will cancel. Okay, so negative x times 3 is negative 3x. 2y times 3 is 6y. 3 times negative 3 is negative 9z. And then 3 times 7 is negative 21. Okay, so these will cancel. Negative 5y plus 6y is y. Z minus 9z is negative 8z. Negative 10 plus 21 is negative 31. Now notice what happened. Okay, what we ended up with is two identical equations. And so at this point, we can stop. I can stop and say, I have two of the same equation, which means, infinitely many solutions. And so this is a dependent system. It doesn't mean that all three of the lines are exactly the same. It just means that two of them are going to intersect an infinite number of times. So it really doesn't matter what the third one is doing. Okay. All right, let's look at an applied problem, so a word problem. A foundry needs to produce 75 tons of an alloy that is 34% copper. It has supplies of 9% copper alloy, 84% copper alloy. How many tons of each must be mixed to obtain the desired result? Okay, these types of problems, you should be looking for one equation which talks about the actual quantity that you need. Okay, so we are looking for, in this case, 75 tons. Then you should have a different equation that looks for the mixture that you need. And in this case, we want it to be 34% copper. So, first equation is actual pounds. So we're looking for a certain amount of mixture A, or mixture X, certain amount of mixture Y, and we want that to equal 75 tons. Okay. For the percentages, I have one of them has 9% copper, so I'm going to let that be X. So 0.09 X plus 84% copper in the other one, so 0.84 Y equals 0.34 percentage overall. So when you go to solve this, solve it whatever method you prefer. I'm comfortable with decimals, so I'm going to solve it by getting rid of X. So I'm going to multiply everything by negative 0.09. And what we end up with is negative 0.09x minus 0.09y equals negative 6.75. And we add them all up. 0.75y equals negative 6.41. So we're going to divide 6.41 by 0.75, and we end up with y is negative 8.55. Now, always check, make sure your answers make sense. I'm looking at this doesn't make any sense at all. I'm saying I need negative 8.55 tons of mixture Y, and that's not super correct. So my guess is I probably put a typo in this slide, but use that method as you go through the word problems in your homework to make sure that you are doing them appropriately. Make sure your answers make sense, right? But either way, pretend this is correct because I have a typo. When I have that for Y, then X minus 8.55 equals 75. And so X is going to be 83.55 tons. Okay, again, I know it doesn't make a lot of sense. Probably a typo. I apologize. All right. The ages of 3 girls, Xenia, Yolanda, and Zaza, are added, and the result is 30. So they're saying if I add Xenia plus Yolanda plus Zaza, I get 30. The sum of Xenia and Yolanda's ages is Zaza's age. Xenia's age subtracted from Yolanda, so Yolanda minus Xenia is half of Zaza's age a year ago. Okay. So we've got kind of a messy scenario here. That's okay, we can deal with that. We're going to rearrange all of this. Like I said, it needs to kind of all be in standard form before you do any of those works. So x plus y plus z equals 30. X plus y minus z equals 0. Negative x plus y, and then I've got half z minus 1/2. So minus 1/2 of z equals negative 1/2. Okay. Kind of looks like I can get rid of the x's without having to multiply anything, so I'm going to go ahead and do that. So x plus y plus z equals 30. Negative x plus y minus 1/2 z equals negative 1/2. So our x's cancel. I've got 2y plus 1/2 z equals 29.5. Take the second and third one, so x plus y minus z equals 0, and negative x plus y minus 0.5 z equals negative 0.5. And again, fractions or decimals are going to be okay here. 2y minus 1.5 z equals negative 0.5. And just for consistency, I'll change this c to a 0.5. Okay, so now I've got two new equations, and I need to make them a new system. Negative 0.5. Okay. And the y's look like they're going to cancel. All I have to do is multiply one of them by negative 1, which basically just changes all of the signs. So 2y plus 2, or 2y minus y is 0. 0.5 plus 1.5 is going to be a 2. 29.5 plus 5 is 30. So z is 15. So Zaza is 15. Once I know that, now we start to work backwards. So z is 15, so 2y minus 1.5 times 15 equals negative 0.5. So 2y minus 1.5 times 15 is going to be, I think, 22.5. Equals negative 0.5, so I'm going to add the 22.5 to both sides. So 2y equals 22, which means that y is 11, so Yesenia is 11, or Yolanda is 11. And then x plus 11 plus 15 equals 30, so x equals 4. Okay, so Xenia is 4, Yolanda is 11, Zaza is 15.